All right, welcome to physics video 7.2. We're going to learn about the direct and inverse square laws. I'm not going to read through the objectives. This video is actually really similar to the last one. In the last video, we learned about direct and inverse variation. Today, we're going to learn about direct and inverse square laws. So that's the deal. The video is going to run very similar to the last one. I should comment real fast, though. I did make a typographical error in the last video, and due to cut and paste, I made it 4 times. So in the 4 examples that I did at the end of the last video, this was originally written, and I've already corrected it for future reference, but when I originally wrote this, I had written, suppose X varies inversely with Y, and I had those flip-flopped. So what it says on the screen is correct now, and to be honest, it doesn't really affect anything because of just sort of the properties of direct and inverse variation. It doesn't really matter. But just for future reference, my worksheets and whatnot are going to be worded the way that it is here. It should be Y varies inversely with X, not the other way around. And then the same is true of the other examples that I did. Okay, the definitions I gave on these slides were good. Okay, so I apologize for the confusion. It really shouldn't affect anything unless you're super mathy. You might have picked up on that and then realized that it didn't really matter. But it will matter today as we do direct and inverse square, which is why I commented on it. Okay, so last time we did direct variation, inverse variation. So today we're going to start with the direct square law and then do inverse square law. So it's almost the same thing. When we did direct variation, what we learned was that Y varies directly with X if Y equals K times X for some constant X, some constant K. All right. The direct square law, you can see the equation is almost the same thing, except that you've got this squared term. Okay. And so basically what that means is because your X is squared, it has a bigger impact on the overall value. So a small change in X creates a very big change in Y. All right. So let me give you a couple examples that you've seen before, and then I'll show you sort of a conceptual example to help you kind of tie this all together. All right. So examples you've seen before. Area of a circle varies directly with the radius squared. Area of a circle is pi times r squared, right? So A is the same thing as Y. Your constant K would be pi, and then your radius is X, right? Okay, so that's an example. Another example, kinetic energy. We just did this, right? Kinetic energy is 1/2 mv squared. So Y would be the kinetic energy, X would be the velocity, and then your constant K would be half of whatever your mass is. Okay, because you know the mass of an object doesn't generally change, so half of the mass would be a constant value. All right. All right. Here's a last example, and I really like this example because it gives a good visual. All right. So it says the number of gallons required to paint the floor of a square garage varies directly with the square of the length of the garage. So check it out. Suppose you've got a garage with a length X. Okay. That's going to take you some number of gallons, right? To find the number of gallons, here's the equation you would do. You'd say, okay, well, the number of gallons I'm going to need then is equal to some constant K. What that constant K would be is I just had this figured out a second ago. It would be the gallons per square foot or square meter or whatever. All right. So maybe it takes, I don't know, I'm going to make up a number. Maybe it takes 1/10 of a gallon to paint a square meter of floor. Okay, so that would be your constant K, and then you multiply that by the area of the garage, which would be its length squared, right? And that would tell you the number of gallons. Okay. But notice, and that's kind of what the bottom of the page down here says, is if I change the length of my garage by some factor, suppose I take the length of my garage and double it. Right? That actually means I'm going to need 4 times as much paint. I'm going to have to take Y and not multiply it by 2, but multiply it by 2 squared. Because check it out. If I double my X on my garage, then what happens is there's X, right? So that's for one dimension, and then my other dimension goes this way. So there's my garage. Let's finish the square. Notice what happened. My original garage had an area of A. My new garage has an area of A times 4, doesn't it? Times 2 squared. Okay? Because X counts twice, because it's a two-dimensional floor, right? The floor of the garage has two dimensions. Okay? And because of that, it affects the area sort of twice, once for each dimension. Okay? So if you change your X a little bit, it creates a big change in your Y. Okay? All right, so that is the direct square law. Inverse square law. Same idea. When we did inverse variation, we learned that y equals k divided by x. Okay? Now for the inverse square law, it's y equals k divided by x squared. Okay? I had a bunch of examples on this. I'm going to just do this one, I think, because this one is the easiest. The main reason we're learning all of this is we're going to learn about force of gravity and electric forces, which both follow the inverse square law. And so it's important that you understand it. And I mean, these, as a scientist, it's important to have a general idea of different mathematical models. So as you're studying data, you can see which of the models the data maps up with. Okay? Cool. So here's an example. So this time, instead of painting our garage, we're going to tile the floor of the garage. All right. So imagine taking your bedroom floor and you decide, I'm going to tile my bedroom floor. All right. The number of tiles that you're going to need, the number of square tiles, y, to cover the floor varies inversely with the square of the width of the tiles, x. All right. In other words, if you want to figure out how many tiles you're going to need, what you're going to do is you're going to take the area of your bedroom, which is a constant, right? You know, maybe your bedroom is 12 feet by 12 feet. That means the area is going to be 144 square feet. Okay, now you got to cover that with tiles. So how many tiles do you need? Well, divide that by the area of each tile. And since the tiles are square, the area of one tile would be x squared, right? Okay. So, you know, like I said, if the area of the bedroom is 144 square feet, that would be your equation. Okay? Now, down at the bottom here, what happens if your tiles get bigger? Right? So we've got this one bedroom, and we're going to cover it in tiles. So, I don't know, right? Now, if your tiles get bigger, what that's going to mean is now, instead of having these little blue tiles, you're going to have these big red tiles. Shoot, I didn't do a very good job of planning this out. But you can see that would take less tiles, right? So what happens is, if the dimensions of the tiles double, then look, those dimensions, when the dimensions doubled, that sort of takes care of 4 tiles, doesn't it? So what that means is the number of tiles you're going to need actually gets divided by 2 squared. Again, once for each dimension. Okay? So that's a quick run through of the direct square law and the inverse square law. So let's do, just like we did in the last video, we're going to do 4 examples. Oh, I lied. Before we get to the examples, I have another visual. This direct square law thing. Here's another example. Imagine that you wanted to build a tower with, just children's blocks, okay? And the conditions of the conditions in building the tower is you only have 16 blocks to work with. In this case, we have 16 blocks. And the base of the tower has to be a square, okay? So in that case, what will happen is the height of the tower, which we're going to call y, is inversely proportional to the width of the base, x, squared. Okay, so check it out. Here's our x, here's our y. Okay, and if you count, I think there should be 16 blocks there. Okay, here's our width, x, here's our height, here's our x, There's our height. Okay, so look, in this first one, the height is 16 and the width is 1. Okay, in the second one, what happened is I doubled my x, right? So my x got multiplied by 2, and the result is, what happened to y? Well, let's see. It went from 16 down to 4. So my y got divided by, not by 2, but by 2 squared, right? In other words, this got multiplied by 2. 1 times 2 is 2. But my y got divided by 2 squared, right? Okay. And then the same pattern follows for the next one. Here, my x is 4, and my y is 1. Okay? So very small changes in x created very big changes in my y. Okay? All right, so now let's do our examples. All right, these are the 4 types of examples you can expect to see in the homework. The first 2 examples are examples where I'm giving you one data point and then asking you to find information about another data point. And then the last 2 examples are examples where I'm describing to you how x changes and asking you to predict what y will do. Okay, so suppose y varies directly with x squared. So once again, this is important because it tells you the relationship. Y varies directly with x squared. So what that tells me is, oh, cool, y varies directly with x squared. So that's the equation, right? So again, I'm going to give you a data point. In this case, x is 4 and y is 48. So A says write an equation that relates x to y. Again, I have that backwards. That should say y to x. Anyway, let's plug in our numbers. We're going to have 48 equals k times 4 squared. So 48 is going to be k times 16. Algebra it up, divide it by 16, and you find out that you get 3 for k, which means that the relationship that connects x and y is y equals 3x squared. Okay? And then part B, once you've done that, part B is easy. It gives you a value of x and asks you to find y, right? So y equals 3x squared. Y equals 3 times, let's see, x is 12. So times 12 squared. So 12 squared is 144. Times 3 is, I think it's 432. I forgot to grab a calculator. And yeah, that's right. Okay, so that right there is going to account for a small chunk of your homework problems. I don't know why I just did that. All right, so that's direct square law. Let's do inverse square law. Okay, so again, the first statement will tell you the relationship between x and y. Here, y varies inversely with x squared, so that means that y is going to be k divided by x squared. It says write an equation that relates the 2 variables again. So once again, plug in your numbers. So here's what we're going to have. We're going to have y, which is 8, equals k divided by x, which is 3 squared. So 8 equals k divided by 9. So to find out k, we're going to multiply both sides by 9. So you get 72 equals k. So my equation is y equals 72 over x squared. So there's my equation for part A. Part B gives you the value of x and asks you to find y. So, well, my voice just did something weird there. So y equals 72 over x is 12, so over 12 squared. So y equals 72 over 12 squared is 144. Grab your calculator and you will discover that y is 0.5. All right. So there you go. Worth noting here, you don't have to realize this, but it'll help us as we move forward, is this. What happened to my x value? Let's see. X was originally 3, and then I multiplied it by 4, right? Because 3 times 4 is 12. So let's see what happened to our y value. Our y value started at 8 and ended up at 0.5. So let's see, x got multiplied by 4. That means that y should get divided by 4 squared, right? So our y should have gotten divided by 16. So 8 divided by 16 is, in fact, 0.5. Okay? So that's just another way of thinking about these problems. Okay? All right, sometimes I will give you different information. Okay, so here I gave you the relationship between them, between the two variables, right? And I've told you that for one value of x, but I didn't give you the value of x. I just said for some value of x, y is 8. And then it says find the value of y if x is tripled. So because of this relationship, because y varies directly with x, what I know is any change in x will affect y twice. Oh, that's not what I wanted to write. I'm sorry. I'll try that again. Because of that relationship, I know that any change in x, in other words, if x gets multiplied by some number, that means that y is going to get multiplied by that same number squared. Or if x gets divided by some number, that means that y is going to get divided by that same number squared. Again, question mark is just some number. So in this problem, it says y is 8, and then in part A it says find the value of y if x is tripled. So x is getting multiplied by 3. That means that y is going to get multiplied by 3 squared. So y is going to get multiplied by 9. Y is 8, right? So 8 times 9 is 72. Okay. And then in part B, same idea. Y is getting divided by 4. So x is getting divided by 4, right? X is divided by 4. That means y is going to get divided by not 4, but 4 squared. So I'm going to take my 8 that y started out at, divide it by 4 squared, and you get 0.5. All right, so that's direct variation. Finally, we are almost done. If y varies inversely with x squared, then the relationship is if x gets multiplied by some number, y gets divided by the same number squared. And if x gets divided by some number, then y gets multiplied by the same number squared, right? Okay. Let me link this one to an example. Our inverse square relationship was tiling your floor, right? So what this statement here is saying is for one value of x, for one size of floor tile, you need 18 tiles to cover your bedroom floor, right? So what question A is saying is what happens if I triple the dimensions of my tile? Okay, so now I've got a tile that's 3 times as big. Well, that means the number of tiles that I'm going to need is going to get divided not by 3, but by 3 squared. So now instead of needing 18 tiles, I'm going to need 18 divided by 9, which is 2 tiles. So obviously a bit of a silly example, but that's the deal. All right. Now, what if the tiles get smaller? What if the dimensions of each tile gets divided by 4? That means you're going to need way more tiles, right? In fact, you're going to need 4 squared times more tiles. So I'm going to take the original number of tiles, which was 18, multiply it by 16, which gives you, what, 256 plus 36 is 292. Is that right? I did that in my head. Let me pop. No, I'm wrong. Oh, that was fun. It gives you 288, not 292. Okay. So anyway, those right there are basically the 4 types of problems you can expect to see. As I did with the last homework assignment, I'm going to be doing a little bit of graphing, so I want you to be able to recognize what these look like. Yeah, cool. We'll practice this in class. The direct and inverse square ones are a little bit trickier because of the squared piece. Okay, but it's basically the same idea. All right, I'm going to shut up because I'm almost up to 20 minutes. Have a good one.